So last week we talked about the periodic table and how it's organized. This week we'll be doing a project about the organization of the periodic table based on the families and how they have different things in common. So these notes are going to help you decide which family you want to choose for your project, and will help you see what kind of characteristics each family shares. So just to review what we learned in terms of where things are located on the periodic table, I just want to remind you that the metals make up the majority of the periodic table, and they're all located to the left of the zigzag line. So some properties that all of the metals share include 5 characteristics. First of all, they all have metallic luster, which means that they're shiny. Most of them are solids at room temperature, but the one that isn't is mercury, and that is a liquid. They also are malleable, which means they can be pounded into a shape. Some of them are more malleable than others. They're also ductile, which means they can be drawn into a wire. And they're also really good conductors of heat and electricity. And so this picture just shows you exactly where the metals are, and they're all in blue. So we have certain types of metals based on the groups of the periodic table. And group 1 is known as the alkali metal group. And so that's like their family name. Kind of like my family name is Parrish. So this family name is alkali. One thing they all have in common is that they all have one valence electron. And we learned this on Friday when we reviewed our lab, that anything in group 1 would only have one valence electron. Because they're all the way over on the left-hand side of the periodic table, they are very reactive. And as you go from top to bottom, they get more and more reactive. So that means that they really like to interact with other elements and create bonds with other elements. So they would rather not be all by themselves in nature. So this just gives you a visual about where they're all located. The alkali metals include these 6 elements: lithium and sodium, potassium, rubidium, cesium, and francium. As we go from left to right on the periodic table, we come to group 2, and the family name for group 2 is alkaline earth metals. These have 2 valence electrons. And these are still, they're close to the edge of the periodic table, so they're pretty reactive, but they're not quite as reactive as the alkali metals. So the very far edges of the periodic table, where you're going to find the most reactive elements. So that's where group 2 is located. Last week we discussed how transition metals take up about 10 columns on the periodic table. So they're groups 3 through 12. And these are transitions because they take us from the really reactive metals to less reactive metals. So they're like a bridge in the periodic table, and they also vary in how many valence electrons they have. Sometimes they have 1, sometimes they have 2, and so they don't really follow the rules that we talked about last week with the group number being a sign of how many valence electrons an element might have. So in the project that we're doing this week, we're actually not going to do any families in the transition metal group because they're a little bit more difficult to study. So they're in this highlighted group that has a little box around it in the middle, this shorter column in the middle of the periodic table. Okay, as we go from left to right, the transition metals bring us over to the nonmetals. And there are actually only 17 nonmetals on the whole table, and they're located to the right of the zigzag line. So properties that they all share are that they don't have luster, which means that they are dull, they're not shiny. They're also usually gases at room temperature. Some of them are liquid, a few are solid. And if they are considered solids, they are not malleable and they are not ductile. So that means that they're brittle. If you try to force them into pounding them into a shape or drawing them into a wire, they'll most likely fall apart or crack or break somehow. So that's what brittle means. Finally, they're poor conductors of heat and electricity, so they're actually better insulators than anything else. So these are actually all the specific nonmetals that are located on the periodic table. And we only have one liquid. Most are gas. There are a few solids. So in our nonmetal groups that have all nonmetals, remember we have the zigzag line that goes through groups 13, 14, 15, and 16. And with that zigzag line, we end up having some metals, some metalloids, and some nonmetals in those families. So they don't all have the same characteristics. But when we get to group 17, we come again to where most of the elements in that group are the same type of element in terms of metal, nonmetal, or metalloid. So this is group 17. They're called halogens. And they go back to following that rule where you look at the ones place in the group number. And so they have 7 valence electrons. And these guys are going to react to form compounds with lots of group 1 alkali metals. So again, this is getting closer to the right edge of the periodic table, and so they're going to be most reactive nonmetals. So they're the highlighted group here, and these numbers up at the top discuss the types of valence electrons and the amount of reactivity they're going to have. Finally, noble gases are located in group 18, and they have 8 valence electrons. Now, we learned when we talked about the Bohr models, when we're drawing out our electrons, when you get to the second level, you can only put 8 electrons in that level before getting kicked out to the third. So because they have 8 valence electrons, they have a full energy shell. So this tells us that they are stable elements because they don't form compounds with any other elements. This means they don't want to have a bond with another element. They have all the electrons that they need. Whenever we have bonds that are formed, these elements either share electrons or they give electrons away to help fill up this energy level. So noble gases don't have any need to make bonds with other elements, so they'd rather stay by themselves. And these are located on the very far edge of the periodic table. So with the exception of noble gases, the further out to the edges you get, the more reactive these elements are going to be. Finally, we do have those metalloids, and there are 7 of them on the table, and they are located on the zigzag line. Remember, not every single element that is touching the zigzag line is a metalloid, so it's important for you to pay attention to that when you're looking at a periodic table that has these highlighted. But this includes boron and silicon, germanium, arsenic, antimony, tellurium, and astatine. Properties of these metalloids include, they have characteristics of both metals and nonmetals, so that's why it's called a metalloid. The most useful property that they have is that they have a varying ability to conduct electricity, so that means it changes and we can actually control it. You can turn it on and off. And so these are most often used in semiconductors. And so this just kind of points out where the metalloids are located. You can follow the zigzag line. Everything that's on top of the zigzag line and touching it is a metalloid, but only 2 on the bottom are metalloids. So right now what we're going to do is talk about our project and just make sure that we know what family we want to pick. And we're going to spend several days this week researching this family and coming up with some characteristics of the elements in this family to include in a photo album to turn in a few days. So let me know if you have any questions, and I think we're going to do a great job on the project.